Yeah, so welcome back from the break. So we both finished with having finished challenge 1 and challenge 2, and we're ready to move on to number 3 and 4. And we also had some interesting questions and discussions and things like that that would be interesting to pick up as well. So I think there's plenty of work to do for the next hour and so. I'm also just very impressed with everybody's been able to set up and learn and to actually make things work. It's a very challenging environment to try to work in, and I'm really happy for your feedback. And I think it works great with you being so active on Telegram and so on. So I think we should just jump into challenge number 3. I'm just going to explain a few things. And it continues very much like the other challenges. And then after challenge number 4, we can maybe talk a little bit more again about why we do what we do and the origin of this workshop and so on. So in this one, we have timeouts and not giving up. So in the last one, we gave up. We just gave up. This is timeout and retries. And one of the things that confuse people in combining policies is like ordering of policies. So it says something about this here, and it also encourages you to try to formulate these requirements as we did before. I'm just going to, because I've made this kind of, you can change from here to here, which gives you sort of an idea of where in the code there might be some traps this time. So it's the and you can ignore all of this stuff that has to do with retries, publish, and set. There's nothing here, but I give some hints against towards ordering of the structure. And I think with that, I'm just going to leave you alone and let you code and run some tests for a while.
So I guess while everyone is getting up to speed, I'll ask you a question about something totally different, which is based on another talk of yours. You mentioned that there was one time when you moved, maybe not one time, when you migrated your project to .NET Core, and from itself it has gained a significant performance boost. Could you tell a bit about it? What version of .NET Core was it? And it's really also really interesting for me that it is possible just from migrating.
Yeah, I can talk a little bit about that. If people get confused by it, maybe they can just take their headsets off or something. So we have a blog, NRK Beta, which is it's a tech blog that NRK blogs at. Most of this is Norwegian journalism and tech, but under the dev section, we blog a little bit on technical topics. So I blog a little bit about architecture and so on here. Just post a link in Telegram because in case someone's interested. And the first one here is written by Almir and Steinar, which is on the playback team, which has been doing a lot of this here as well. And they talk about how the 99 percentile went from 4,000 to 10 milliseconds. And this was a lot to do while we worked on these things. So there are several things that has to do with this. We go through this a little bit in detail, but we did see, these are some slides from an internal tool.
Nice picture.
Yeah, and it's crazy, right? We were like, what's going on here? And I don't know.
I need to show this one to my customer.
Yeah. there were many things we did to get the percentile from 4,000 to 10 milliseconds, and some of those has to do with we were not doing an external call, and this pure change here in .NET Core made, as you see, this is just moving to .NET Core, but when we were moving to .NET Core, of course, we're not just moving to .NET Core. We were moving from running the full .NET framework on IIS in a web application to running .NET Core on Alpine Linux in the Docker. So this might be Linux, because we see, as I said, I mentioned in the workshop, when I did this workshop before I put everything into Docker, I had everything just on .NET Core, just plain .NET Core. And there were massive differences between Windows and Linux and Mac machines. So the people who were running on Mac and Linux just had so much better performance. It was difficult to come up with sort of retry assignments that would work on Windows and Linux for this workshop. So,
and that gives you a hint that it's nice to transition to Linux because it's faster.
Yeah, I mean, I'm not going to try to be a system expert in any way. I don't know what goes on in Linux and Windows, and I have no idea. We can just say what we observed, but the differences are massive, especially in the 99 percentile and so on. When things get loaded, it's
yeah. So with Docker and .NET Core, there are really some cool things possible. So people starting to.
Yeah. So there's a question. Yes, you can see. You can see. Yeah, you can see what went wrong, but not the threshold. So if you don't open the file, you don't really. I don't think you can see what. Because it says that there's a red X and it says that the 200 OK rate failed. And that's not the target. That is the number of requests that failed and the number that were successful. So it's not the target, and these are the actual values. So K6 doesn't actually print out the expected. This is just the actual and failed. So from a normal test, it's a good question. From a normal test, you would have like actual and expected, and they did not match kind of thing. So you would expect like, I expected the 200 OK to be 99%, but it was 88%. Therefore, it failed. That's something to discuss with the K6, I think, because that would be a very nice feature. So no, unfortunately, in the workshop, you need to open. But the people at K6 are very. We've been working with them commercially as well, because we use their cloud offering as well, which allows you to run these scripts just in the cloud, so you can scale them up for much higher loads. And they're quite friendly and developer friendly to work with. So I think Nikolai is a very good feature request for K6 to print the actual threshold targets. What they do, which I could show, is they do that in the actual product. So if I show you, if you upload this in K6 and you run a real test like we have here, this is like a periodic test that we run. So you see we run 8 million requests over 22 minutes with 5,000 virtual users. We split them over 2 data centers. So this is just uploaded to K6. And we get this 16,000 requests per second. And you can see we have, and in here we have thresholds. So in here you can actually see the thresholds and what they were and why they failed. And you can see all the checks that are done. So it might be that this is something that they sort of include in their dashboard offering, or it might be a nice feature. So I can see that Anton has made the assignment, so maybe you can post your settings as well. And I'll just wait for people to
give a bit of time for others as well.
Yep.
Um, so that K6 dashboard that you showed, I understand that there you make the kind of the massive load tests on pre-production, right? When you need to, like weekly or something. And you also mentioned that you also have some maybe lighter load tests as a part of your Azure DevOps. Is that the case? And can you tell a bit how is it set up? Because it's really interesting.
This is where I can pull the architect card and I say I made a workshop and I've sort of, it's the team that do all this hard stuff. So exactly how it's wired into Azure DevOps, I don't know, but it is set up as part of the Azure DevOps pipeline. And since K6 and all of these things run in Docker images, I say straightforward, but I haven't done it myself. So, but they deploy the application as it's a part of the deployment step. They can run similar tests to this to see that things are actually.
So the idea is that the tests are formulated in this rigorous way that you need to have 99 percentile such, etc., etc. And if it fails, then the whole pipeline fails, right?
Yeah. So if you do something, let's say you load some documents from the databases, just takes a very long time, and things now are much slower than they used to be, then you would fail a test. So you can do these smoke tests or kind of load tests as part of that. Then we have some machines that run continuously, but not that high. So the testers have some kind of loads that just runs continuously, which is what you saw before when we saw that massive drop, which is more like they have their own machines that just run K6 basically almost all the time. And then we have this stress tests that we call them, which would be very expensive to run all the time because they are generating a lot of load. And they are so large that they, in our case, we trigger the auto-scaling mechanisms in Azure. So we can see that when the load ramps up, the application spins up more instances, and we can make sure that we're adhering to these SLOs during scaling operations. Because what we saw before was that people said, oh, it's not a problem with load because we have auto-scaling. But then if the auto-scaling operation takes 10 minutes, then the application will crash. So we can actually guarantee that we can scale and perform during scaling. And this is something we've been testing, and we can also then see that we can do this in production. And another
actually,
good thing
this is something I didn't. Sorry.
Yeah, no, just.
I didn't think about it, but obviously, yes, it can be really expensive because if you test, you do the load testing, you can make Azure to spin up very many instances, and so it can actually cost quite a bit.
Yes, and it will cost you just traffic and so on. So you can't do it all the time with that kind of scale, or well, you can. It's a budget question, really. But the biggest ones you want to run from time to time and test things, but you can also save money on it, which is interesting because sometimes we run, or I think a lot of people run with more capacity than they have to because you don't trust your auto scaling. Like.
Yeah.
You could run with one instance and turn on auto scaling, but you don't trust that it actually works. But if you can test it, you can become confident that the auto scaling actually works. And then you can be more aggressive on scaling down instances and having the mechanisms. So I think that it's possible to use this also to be confident in scaling down and using that kind of So there are many things that sort of open up once we start getting into this.
So it looks like people are getting good results.
Yeah. So as you can see in the screenshot here from Anton in the Telegram Slack, he has 2 retries and 90 milliseconds timeout, and swapped, which is the, I hinted at, you swapped the order of the retry and timeout policy. So the reasoning for this, I'll show you in the code here, is that this is the inner loop. So this is what happens first, and this is what happens next. So you could sort of draw this as a block diagram if you like. And if you retry first and then you time out afterwards, then there's no one that is going to retry when you time out. So the typical way to order this is to have a timeout policy here, and then to have the timeout policy first, so you time out and then you retry. And it's the same thing basically we do with the chaos policy. So you put the Simmy monkey first, and then you put the retry mechanisms around it. Like it's the same thing here. You can try for yourself if you want to later, but if you put your resiliency strategy on the inside and your monkey on the outside, then everything is going to be chaos, right? Because there's no one to look after the monkey. So I don't know if there's any good ways to remember this, but drawing block diagrams works. Maybe put them, I don't know, put the monkey on the right side. Could be a rule. So and this is something like if you don't test it and you observe how it works like we do now, I think it's very easy that these kind of bugs just go out in production. That's at least my experience. And you can have done a lot of nice things here, but if you don't test it properly, then, well, this could also be unit tested, of course, but it's, yeah. So we can, I think we can just move on to the challenge 4, which I think is like, my goal is to get to this one. I think if people understand challenge 4, which is basically 1, 2, and 3 just combined, then I think, you know, for most, that's the main thing I want to teach, I think. That's the main idea. Everything else that comes afterwards here are implementation details and .NET specific stuff. That's typically things you do. So challenge 4 is very much the same, but what you see here is that we combined we have a latency monkey and an error monkey. And we use the same kind of wrap thing to wrap the latency and the error monkey into one monkey policy that will both fail and have latency. And then we put that, of course, as we mentioned, on the right side and the policy on the outside. And the policy is pretty much the same as the other ones. So if you could formulate the kind of given when then based on the tests here, and see if you can come up with some values and solve it. And after that, I think we could take some time reflecting and discussing with you the setting of these parameters. And then I'm going to try to be quiet for a while.
I'm muted. So you also mentioned that one of the things that you have tested for, which is of course useful, is the situation when all of your Azure instances go down simultaneously, and that you, even in this case, were able to meet your requirements. And to me, it sounds like magic. I don't understand how this is possible. So is it just Azure that is so magically fast, or how
no,
is it at all possible?
That was just restarting the applications. We tested because one problem that we had was that there was some kind of it's an environment setting in Azure App Services, and if you don't set that, Azure at some random point restarts all your services at once. So we had 10 instances of this API running, and then they all restarted at once. And when that happened during load, the application would not come up again. And after we did this and we split the application and so on, then we were able to restart the applications under load. But that was just like a pure
obviously
restart.
to restart, right? To be warmed up. So all the performance indicators must fail.
Yeah, but it also depends on how you measure performance, because normally you measure your percentiles over a period of time. So your 99 percentile is measured over maybe 1 minute or 10 minutes or so on. And you might have so there's a lot of trickery that goes into measurement that can cover over some things, right?
I see. So at some point you have a lot of waiting, but then the second, like in 5 minutes, they all go fast.
Yeah.
That must be.
But I think I think also that was one question that was before that had to do with bulkheads. And what we have been doing, I think, in the most performance critical parts of the API, it's not, instead of using bulkheads, which is an advanced poly strategy, which you can absolutely use, we've been using containers and splitting things up into separate APIs. So a lot of these APIs are much smaller now, so the API is just doing one thing. So there's one, and the one that was very fast and that is working all the time, no matter what you do to it, is the one to play linear channels. So it's the one that is the one that plays a classical TV channel. I can show what I mean here, because like if you click and you want to play a channel 1, 2, 3, right? So we have a few channels and you can play one of these channels. There's nothing here. Oh, this is back to the 80s program. So this looks, that's why it's...
I see, yes.
These are more like, not everything is old, these are news. But the configuration of the channels is static, right? So you can put it in the database, but it changes so rarely. So that actually, we built a lot of mechanisms around that. Like if you don't find the database and use a memory caching strategy, if you can't find it in memory, then just use this document that we checked into source control, right? So we had the situation in the beginning where if you lost access to the database, then the API would crash. But after we started doing this, we realized that one specific API can run without a database, because you can check in the configuration into source control and just keep it there if you can't find anything. So that's why that's very, very fast, right? And for the programs, you can't do that because you need to find it in the database, but you can at least use very aggressive caching strategies and so on to survive
so, yes,
for a while.
This is really interesting to know this kind of principles. Also, you were saying that you previously had like one monolithic application, and then you started to look at which parts of it are kind of mission critical that need to be up all the time, and which of them are okay if they fail a bit more. So it's interesting to know what was your road of splitting this big monster into bits. It's obviously something that is very useful for many applications that are several years old.
Yeah. So there's all these kinds of things that happens, and one of the thing about the monolithic application is that it typically also has like a monolithic retry strategy. Like you have one database where you put all your data, then you have one database access layer that you use to access the data, and then you put one resiliency strategy on top. And you get that kind of thing where your resiliency strategy is maybe not good for any of the cases, right? Because it turns out that a lot of these things have different behaviors, and some things you want to give up early, some things you want to retry, some things you can cache in a different way than the others, and yeah. Yeah.
Mm-hmm.
So
Yeah.
it's really fun to work with, and I mean you can spend an infinite amount of time on this. So it's also very good to know what you're, as you talk about, to figure out what are you trying to solve, and what is important for you, because you can retry and build
Well,
resiliency without. Yeah.
one of the problem is that if one thing fails, then everything else fails. Then it's that it's nice to have like smaller services. So it looks like we have a lot of answers, and people are formulating the goals.
Yeah. So people have. I think this is like. It looks like everybody's understanding what's going on here. There's some good discussions on.
There are also some
Some good input.
questions like, does it really matter how many
Yeah,
users are in the test case? 10
10
or 1 or
or
100?
yeah, it's that VU, the virtual user thing, virtual users, which is a K6 concept. I actually don't know. I thought so. It might be possible. I haven't tried it to set. That's a good question. If you do the let's say the challenge intro, and like if you add one virtual user, can you still do 500 requests per second? I'm not really sure if you can do that. When you run locally, I'm not sure. When you run in K6 Cloud and you run this thing, this has to do with how many, then I know you need to scale up, because you actually pay for the number of virtual users, and that has to do with, where's the RPS? With one virtual user, I can only, it doesn't look like I can get a lot of requests. So it has something to do with the, how much you can scale the concurrency of this thing. But I don't have like a good answer. You would have to talk to the K6 people to figure out how it really works. It's a little bit of a, so I tend to normally just scale it up until I can, get the request rate I want. And Nikolai says that when he increases the number of requests to 500, it's no longer passing. And this is probably true. Like that's why it's also part of this workshop to figure out like how much can one instance do. And normally you would not run your load test on the same machine as is running the application, because you don't really know what is causing the thing to be slow. Is it the load test that's failing, or is it the machine under test that's failing? So yeah.
People are saying that the main question is
Yeah.
how to use math to figure out the correct answer without using brute force.
Yeah, and this is the thing, and this is why I think I wanted to have a discussion now after Challenge 4. So I'm very glad the discussion is starting by itself, because this is the difficult part about this. This is where we can talk about engineering becoming art, like, or I feel at this point we are doing more engineering and less just best effort. Let's just do something. We are talking about the rates of failure, the rate of latency, how many requests per second. So you have formulated some requirements that you could say that, okay, if I build this API and I run it on a 2-core Linux machine with 4 GB of RAM in Docker on Alpine, and I only have this much errors in the application and this much latency, then I can do 500 requests per second. So you can specify it, right? You can say how your application will perform, and not just say that it's fast or it's the best or it's .NET Core or something. But how to come up with the specification is the engineering art of it. So what we have been doing to try to give an answer is we've been looking at production data and saying we're going to we're always going to test for, let's say, the double or the triple of what we have ever seen. Like we are going to so when our numbers now go up during Corona, we'll increase what we load test for. So we always have some kind of margin, right? But I would like to sort of flip that around. So if you could come up with something in the Telegram chat, that would be cool as well. Because this is what I find is that it becomes a discussion that becomes very concrete. So that the tech leads and developers and the testers and so on can have these discussions, and we can say that, okay, but okay, so these are the numbers, and then when someone comes and say, oh, can this API, can we use it for in this use case? Can we load it with this many users? Or what happens if we expect the number of users to go up by 4? Will it still work? Then we can say, we can test for it. We can change the requirements. We can say that, okay, if you want to have, if you want to sell this product to five times as many users, then we can increase or stress test by a factor of 5, and we can see if it still performs to the guarantees that we have been running with today. So we can sort of take the discussions that sometimes are very vague and make them very specific. But no one is going to come up with these numbers for you, so yeah. And another interesting side effect about this has been that when people are monitoring production and things are becoming slower, maybe something is twice as slow, maybe it took 20 milliseconds instead of 10 milliseconds, then we can say, are we going to fix it or not? And then we can look at our specification, we can say, it's still fine, like our specification says it has to be better than 100 milliseconds, and we're, at 20 or 10, like we don't have to really worry about that, right? So, and the other thing is that we do now is that if the API suddenly then take 200 milliseconds, maybe it still works for the user, but we can say that now our API is down, so we can go to the product owner or the team leader or something and say that by definition now our API was down, so we need to work on investing more in doing resiliency work, or we need to change the requirements of this API. So what used to be quite vague has become very concrete and something we can talk about. I think that's maybe the biggest change, and then the numbers themselves is just something you need to work on. But what you measure is something I think is more maybe generic, and I think this 95 or 99 percentile is quite useful. And I would say that the rate of 500 internal errors, 200 okay is a bad measurement, really. This is just for the workshop. Because 404 can be, maybe it's not your fault, right? So what we normally look at is 500. What we normally look at is what is the rate of 500 errors? That should be less than something. This is what we typically would look at in production. And the percent and also how many exceptions do we log internally and so on. And I think the Google book is quite good on talking about that. And then there's more about calculating the numbers, some sort of public Excel docs. I don't know. I don't really have a good answer to.
You mentioned some Google Docs.
Yeah, I think I put
some
the
Google link sites.
in. Yeah, I can put it
perhaps
in
that
again.
is
I
a
put it in
reference.
before. Yeah, so the Google SRE book is pretty good. It's I put the link in again now, and there's a lot of things in here, and this service level objectives is really what we're talking about now. So you have an indicator which is what you measure, which could be request latency, error rate, system throughput. Like if your throughput is too low, then something must be wrong. Maybe you're not getting traffic. And then you have the objectives, and this talks about it talks about this different choices and so on.
I also thought
But
that
it's hard.
yeah.
Yeah.
So
So see.
it is probably useful if you have some some objective and you still have some like you want to be less than 100 and you are now gone from 10 to 20 and it's fine, but then when you get to 90, then it's something that you need to work on so that you can fix things before they are completely broken. So that is, I think, a useful approach.
Yeah. So yeah, and I think it sort of it sort of matures during time, is my experience. And it gives people more incentive to look into the runtime. We have a joke internally now where we say runtime errors are also bugs, or because it used to be, I think, before that, like we as developer you develop something and the testers test it, and if it works, then it doesn't have bugs, right? Because production was something we never got to see, and with DevOps, all of that is changing, and we get to get insight in what is happening in production as well, and we sort of need to look more into that. So
People are asking whether we go in to walk through all the examples. It looks like they want to do some more.
yeah, and so I think we can there's just one more question about you launch this. Some have this as part of continuous deployment. So they have similar tests like this for continuous deployment in Azure DevOps, and it's built pretty much like the workshop here. And yeah, the presentation is in the repo, but it's not that useful, I think. But you can have a look at it. But the
So that will be
presentations on video
the
are
video of today.
then. But we can move on to the next challenge, I think. So now, what we talk about in challenge 5 is something we've just glossed over until now, but it has to do with pessimistic and optimistic timeout strategies. And now we get into .NET and tasks and synchronous execution, and it all gets a bit complex, but we are just going to ignore the stuff about pessimistic timeout, and you can read about it if you like. But what we are going to work at now is the right way to do things in .NET, and that's using optimistic timeout strategies, which is using what we call cooperative cancellation, and this has to do with passing cancellation tokens. So I think in Node.js, for example, I'm not really sure this is possible in the async model. So this is like .NET specific. So and the cancellation tokens they've been there all the time. I think you see here we say cancellation token none. So they've been in all the challenges. We just have not talked about it. And the cancellation token none it just means that you get an empty cancellation token. So it means that it's initialized from here. You could have it from somewhere else, and that's what we're going to talk about now. But this one just initializes it. It passes it in here and then in here. And then this cancellation token is passed into this method and it's been fed into task delay. So if you do, it's the same thing if you do an HTTP call. So if you don't pass this cancellation token, we'll look at what happens then, right? And cooperative cancellation or optimistic timeout relies on us understanding how to pass these around. And if you don't do that, then the Poly and Simmy and whatever resiliency framework you are using will not work as intended. So in this challenge, it's sort of like number 2. We want to cancel a request so they don't take longer than 100 milliseconds. So if you look at challenge 5, basically it starts with running test 5. And when you run this, we see that we have a timeout of 20 milliseconds, but the request duration is 2 seconds, because there is a 2-second delay in this case. I'm not using Simmy, I'm just using task delay. There is a 2-second delay in 5% of the cases. You can read the code and have a look at it. And we have a policy that we use to get the forecasts with a timeout of 20 milliseconds, but it doesn't work, right? So what I would like you to do is to change the signatures on these methods so that the cancellation method, the cancellation functions work. And you can look at as I said, you can look at challenge 2 if you need some input on how to do it. This confused me for so long before I understood this, how to do it. I was really confused. So I've been trying to make some challenges where you can like learn how to do it and get confident on how it works.
So basically, the idea is to cancel everything that takes longer than a certain amount of time, right?
Yes, everything that takes longer than 20 milliseconds, or it said, not here it's 20, but it says, I think it says 100. What does the test say? The test is the right one. The documentation might be a little bit off. The test says, the test is 100 milliseconds.
100, yeah, it's the same in the doc.
Yeah, so the documentation.
So yes, if some service starts to respond very, very slowly, then it can just crash the whole system. And for example, if the service is not so crucial for you, then it's useful to just cancel.
Yeah, so that could be a case, and and in this case, we just want to make sure that it actually cancels, because what happened when you look at it is that it's like it doesn't work, right? We've added a timeout, we added Simmy to the timeout, but it still takes 2 seconds. So we have in the code here a policy that times out after 20 milliseconds, but still it takes 2 seconds because we're doing something wrong, right? So this is what I would like you to fix. In most workshops, I've been actually doing this more as a demo than as a task, but since you have been doing so well, I'm going to let you try to do it.
While people are thinking, there are some more questions you may want to ask. For example, if we don't have strict requirement, we have requirement to keep the same performance and reliability. Vadim is asking.
Yeah. To get this.
This is the talk.
How you get what is doing there? Yeah. So what we've been doing to answer Vadim's question, like if you don't know, like what is your system, how is the system performing today? Personally, what we have been doing is to use production data. So we use application insights in production, but there are, you can use Grafana, something that logs the performance of the existing system, and you just say, what is the maximum load we have, what is the maximum latency we have, in 99 percentile, not maximum, 99 percentile, what are the error rates we have today, and you can use that as a starting point. Because if you run something, if you just run 1,000 requests per second, as you can do here, most systems don't have 1,000 requests per second, like in production. Like even when I look at our production stats, like with HTTP caching and with normal usage modes and so on, a lot of APIs or smaller APIs don't really have that much traffic all of the time. So if you try to, so what we do is we have production dashboards. So we say what are the peak requests per second, and for example, for some of these, we can look them up online right now. I'm not sure if I can show it to you because it's. But if I look at some of this data, I see that the maximum we've had for the last 3 days, maybe 200 requests per second on one URL, right? And that you can easily handle with one machine. And then it's so just looking at the production data and see what you have to do, maybe multiply it, the maximum request per second, multiply it by, I don't know, 3 pi something, and then you say we're going to load test this against that's a good way, I think, to do it. And the other way is, of course, to load test it until it crashes in pre-production or something. That's this sort of torture test, and you just load test it until it dies. But I'm not sure if that always. Yeah, I try not to say too much about it because I feel like getting very prescriptive about this. Chances are I'm wrong. Like I'm not. It's yeah. So
it looks like people get some good results.
Yeah. And this is this challenge is about the Poly API, and that's true, right? It's about how to use Poly properly, but it's also a little bit about how to use cancellation tokens, which is
cancel.
Which is .NET's way of canceling it, because task delay or HTTP client or everything uses it. Like I don't know if I have a HTTP. If I make oh, this was not very fast, was it? Not that. Here is it? Where can I find it? Why? It's the system at HTTP, I guess. I don't have a lot of help in. Yeah. So if you get async, some kind of URL. In Norway, we always use this biggest newspaper, which is a competitor of NRK, really, when we want to test a new site. And then you have like HTTP complete options, and you have cancellation token, right? And so it's the same in here if you don't put it in. So yeah, how we do it has to do with Poly, but also how .NET does cancellation. And if you don't put in the cancellation token in here, you can put in as much resiliency mechanisms as you want to. But if you don't pass it along to your HTTP client, then it's not going to work, right? Yeah. So yeah, now cancellation token source. I can just show. I actually wanted to. This is something where I want to sort of address the open source way of working. This workshop is not mine as per se. So if someone wants to make some challenges that like explains these things or other things, just like feel free to make unit tests or new challenges that explains, bolt tests or these things. But the cancellation token source, I think I understand. I can just put in something. So if I may, we're going to get a little bit into it. So a cancellation token source is something you can make, and you can get its token. So this token, I can check if it's cancellation required. And there is a challenge that is coming on that at the end, which I'm not sure if you have time to do, but you can run it yourself. So you can do if, but the token is something you pass around. But this one is the one you can cancel, really. So it has to do with So you make a cancellation token source, and you can do a cancellation on it, and you can pass that token in that around. And we get a little bit into how this works.
Perhaps people are confused that you need both first token source and then token. Why not create just new token?
Yeah, I honestly haven't digged that much into it, because what I've found is that in many cases in the web application, I will show you some example of it. I think that's challenge 6 maybe, or 7. We'll see. Yeah, because token is struct, it says. Okay, so token is this cheaper, I guess, value to pass around.
So you have one source and many tokens from it.
Yeah, and if it's like, I think I better not try to explain something that I don't understand perfectly, and we can have the discussion later, or maybe Sergey can actually explain it in the chat.
There will be a discussion afterwards, so yes, there will be possible to.
I don't want to pose this as an expert in something I'm not, so I'll but the main thing we're going to do now, it looks like people made it work, so wired it up properly. So yeah, this is a little bit yeah, and this is a very similar challenge as the previous one, but we're going to use the cancellation token from the controller instead of creating one. And this is interesting, I think, just because I didn't know, and a lot of people don't know, that you can actually get it from the controller. So you can run the challenge, and there should be some hint. Yeah, there is a hint here, right? That if you just in ASP.NET, if you just add the cancellation token to your method, the framework will inject the cancellation token for you. And we could have a look at how that works. So let's see if you can run challenge 6 and use that cancellation token. Because now we have the same situation that we had before. There's no passing around of it, right? Yeah. But what is also I think it's interesting is just that, like, if you want to start with a cancellation token that only Poly has control of, then you just, as you said, in none. It's really default in many ways, or like you get an empty cancellation token that Poly can use to cancel stuff. But yeah, you can go infinitely deep in understanding .NET internals here. Looks like I've made that injection work, yeah. So in this case, it's automatically injected from the framework, and you can really do the same thing in here. So you pass it in like this, and then you need to accept it here, and here, and it's like async. It just goes in everywhere once you start using it. But then you can add it here and here. And The sixth one is you just pass the controller argument down to policy execute async. Yeah. Now there is a question that we're probably not going to get to, but I can ask you to in the chat. What do you think is the main difference that happens if you use this one from the controller, or if you use this one from here? Like, what is the difference? See if someone has any ideas. I have no idea if people are thinking or writing or just are confused, but it's
yeah, writing.
Yeah. I'm going to give people a chance to. Yeah, right. Because the client or server codes decide. Yeah, you can cancel from the outside, right? So what happens when you pass it in here is that it's actually bound to the entire HTTP pipeline. So this challenge 11, we're not going to do it now, I think, so I can just show it to you, and those who are interested can do it later. But this is like an extra challenge that you can play with, where we set K6 up to do this. Hold on, let me see if I can find it. Timeout. This means that the K6 load test is going to close the HTTP connection or close the TCP connection. At least can't close the TCP connection after 50 milliseconds. And I made a challenge which I think was pretty funny, which is this kind of recursive function in the controller that it delays 1 millisecond and it counts to 100. And if you don't cancel it before it gets to 100, it does a system environment exit and it just stops the web application and it kills the application. So basically, this means that if an HTTP call comes into this controller and this function is not canceled in 100 milliseconds approximately, it's going to crash the entire web application. And this means that you need to wire it up properly, because if you use this one, you don't know that K6 has closed your connection, so the controller will continue to run. But if you wire it up to here, then you will actually cancel all the things. And if you have some time, we can yeah, okay, yeah. And there are some benefits of doing this, and there are some downsides of doing it, and we can discuss that later. Now, challenge 7 is something that might seem very obvious once you explain it, but I'm going to talk about something that we have had in production for many years. So it has to do with idempotency and retrying. And it says, hint, look for what the system invalid operation exception says. And this one you can find if you run challenge 7. You can find it in run and watch web API, where it should where you should see some exceptions once this runs. We see some exceptions, and there should be some exceptions here that will give you some hints on what is wrong. And the assignment on this to discuss in the chat. Why is it wrong, and what's happening, and so on. And we'll discuss in a few minutes. Oh, there's something wrong in this as well. I think this should not. This is something you might also need to actually change this URL to be HTTP and 5000 and not HTTPS and 5001. I think I changed it in the last update, but yeah. So HTTP and 5000, and try to see what's happening.
So while people are thinking, another question about K6 itself. Why did you choose it, and what are the alternatives?
Yeah, I think there's a lot of alternatives on the market. The first version I had was using Challenge 7 has HTTP and 5000. Yeah, I updated it, so I think if you clone the repository yesterday or the day before, you have it. Yeah. I use NBomber, which is quite cool, which is a .NET load testing framework, which I like quite a lot. Then there's what we used to have was what's that Java framework that everybody used to use? JMeter, I think. JMeter, yeah, Apache JMeter, which is one which we have been using for a while, but developers didn't like it. I didn't like it. It felt old, like there were. It's probably good. I just and there's Gatling, I think is pretty huge. Gatling IO. So there are lots of sort of tools on the market.
Are they similar? Are they very different? Does it matter at all which one to choose?
I think JMeter, as I mentioned, is getting a bit old again, and Bomber is very .NET specific.
So if you use .NET, that it's probably a good choice.
Yeah, I would think that's a good choice. The reason we didn't choose it is because we wanted I think I'm not going to do like a sales pitch for K6 here, but I think because I'm not getting paid by K6 to promote them, and I work for a public company, so I can't really. But I still would like to give them a shout out just because it's quite developer friendly and it's very easy to take what you have locally and run it in the cloud and sort of scale it out when you have to, but you can run it perfectly fine from your own machines, open source when you want to. So it had a lot to do with that, and there were yeah. So yeah, or and Bomber as well worked very well. Like it's yeah. Yeah. So you can give a shout out to K6 at Twitter if you like. It's like a startup. It's not. I don't think it's a really large company yet. But we use them, and I know quite a lot of companies in Norway have started using it for load testing. Yeah, work. It's probably good as well. Like I mean, these load testing tools in many ways. I mean, it's yeah, it's probably like they've done with NBomber. It's probably something that would be fun to write yourself as well. Like, I mean, you're just generating a lot of traffic. So yeah, I would say just pick and choose the one you prefer. I don't know how if anyone has like figured out Challenge 7 yet. I don't know if it's very.
I'm not sure. So somebody written that Challenge 7 it doesn't have the correct. No, it's about.
Yeah, but it's a bit. The challenges are getting a bit weird now. Like the 1, 2, 3, and 4 were more like, I don't know, straightforward to explain. Now it's just me being, I don't know, I'm being tricky on purpose, I guess, and I don't know how easy it is to understand the
But
assignment.
I understand that it's from real life, right? That the issue that you had yourself.
Yeah. So I can show it in a while if just give people a few more minutes to.
There's a question.
If you move the throw before send async, would that be fair? Yeah. There's yeah. I think you can move stuff around. I think I'm just going to explain what's going on because I'm not sure people understood the assignment. That's a bit unclear. So the whole idea, let Anton finish his typing and I'll see. Yeah. Well, yeah, that's the thing. You can move those lines, but you can also change the signatures. That's why I'm a bit annoyed with myself with this the text of this challenge, because you can move those lines to other methods, but you also can change the method signatures then. Yeah. But those are like the main two lines that needs to be moved around. And then if you move these two lines, then you don't need to pass this message around. And then yeah, and as Lev says, yeah, the problem is the retry policy. We try to say the same message several times, right? Yeah, and in a way, you would think that doing a get several times is fine, right? And it is. I think if you had done a get HTTP get, it would probably be fine to do it several times. But this request message takes care. Yeah, spoilers. Yeah. Yeah, you can do. That's a fine way of doing it. Like, it's probably not what you would do in the. But that's the point, right? So, and get forecasts, right? Yeah, and that's what Anton is doing is fine as well, or is what I normally would do. But the first one was funny as well. So you can move it down here, and we can take this away, and then everything will work. And I guess the interesting part about this is the story, because as was mentioned, we had quite a monolithic application, and then like a monolithic data layer, and you had some, as you do in the enterprise, you have some kind of your way of doing HTTP calls. And what happens then is that we had this generic method that would retry HTTP things. And the thing is, HTTP message takes care of whether it has been sent. And the reason it does is because that you can do HTTP request messages that can only be sent once, because maybe you have a stream that you're streaming into it. Maybe so you can only send it once. After it's been read by and sent, you cannot send it again. Or so HTTP request message can only be sent once. And what we do here is we make a new one. So every time you retry now, we make a new message and we send it again. And that's fine. We can do as many times as we like. But this one can only be sent once. So if you try to retry it, it fails. So what happened in production when we had this kind of generic way to retry stuff was that what I saw in the logs, and this had been in production for a long time, was that the first, like when everything worked, it was fine. But the first time HTTP call failed, it would fail, and then Polly would try to retry it, send it twice, and the framework would say it cannot resend message, and it would crash. So it was like everybody thought it had resiliency, but it just didn't work, right? So we had this in production for many years, and yeah, and the as it says, challenge 7 is an easy kind of idempotency, right? For example, it does changes. Can you advise some strategies of handling retry scenarios? And the only strategy I can, as you say, you cannot retry if something is not idempotent. So the only strategy I can give is make sure that you design your system such that operations are idempotent, right? So And this, I know that's a bit of a cop-out answer, but it's also unfortunately probably true that you need, if you send a message to another system, you need to design it such that the message is idempotent, so you can try to send it again. And if you don't, then you will have problems when things starts failing, because messages can be sent many times and 0 times and retried and come in different order and all of these things, as we know. And you need to do very hard design decisions to make it work. And if not, then everything else is going to be hard, and there's nothing Poly can do about poor system design, really. Like, you cannot make a strategy that retries things over the network if the application is not idempotent, really. So it comes down to, you need to design. Well, in this case, you can of course fix it, because as you said, it was just like it was done in the wrong way, and if you do it in the right way, then now it works. But in some cases, you probably need to design it such that the receiving end filters it out and say, I've seen this message before, I'm not going to do it twice, or I haven't seen it before, or, yeah. I think we are running out of time, but we're also running out of challenges, so that's a good thing. This one, challenge 8, is called Thinking Fast and Slow, and I can at least show it to you so you can run it yourself. And what I've been doing here is that we have, and this is also based on some real life cases, because we have, I'll show it to you. We have most of our TV shows are like, on Netflix, this is the Christmas calendar, right? It has 24 episodes and that's it, right? So loading this series, it doesn't take too long. Then you have the news, which NRK has been sending since forever, and we have everything here, so you can basically look, what are the news in October and September, and you have all the news. So these can be resources that are much heavier to load, right? So what should the timeout be when you have a huge document and a small document? So this is what we're trying to sort of simulate here by saying, some documents take longer than others. So, ID1 takes 1,000 milliseconds and the other ones take 20. Now, what are your timeout values going to be, right? How long are you going to wait? How long are you going to retry? And in this case, we've done some more advanced retry strategies. So this shows how to add state to a retry mechanism. So you can sort of thread safe and per retry add some state to it. And it's better explained in the Stack Overflow post here than in what I can do online. But but this is the stuff you can try on your own, really. See if you can figure out. So, but the whole idea here is then to run on different resources, and we have in K6. I just do, I made this is K6 is just JavaScript, so you can make some URLs, and this is the one that will go slow, and I'll just choose at random one of them and get that. So this is one of the nice things I think about K6 is
Hi
that
guys.
Yeah, hi.
I now come back. Did you complete all plans for second part today of your workshop?
Yeah, I came much longer than I ever hoped to. I was really happy people got everything running. As I mentioned, I wanted everybody to do 1, 2, 3, and 4, and we've been able to go a little bit further than that and have some discussions. So yeah, I'm happy it didn't go faster because I don't have more
It's awesome.
content really.
Maria,
So
есть
I
ли у
think
вас
we'll
вопросы?
invite everyone to the Zoom now, because I think we have several questions more to discuss. So yeah, let's continue there.
Okay, let's go.